needles. The artist aligns these small needles in a jig, then solders them together onto one end of a steel rod. There's an eye on the other end. The number of small needles in a needle depends on the tattoo design, how thick its lines are, how big its colored areas are. The finished needles go into an autoclave to be sterilized. That takes 20 minutes at precisely 170 degrees Celsius. The tattoo artist uses that time to assemble the tattoo gun. After cleaning the frame with rubbing alcohol, he installs the motor called the coil. When an electric current runs through the coil, it oscillates the needle at up to 50 times per second. Once the two needles are sterilized, he takes the one for outlining, called the liner, and slides it into the tattoo gun. He hooks the eye on the other end onto the spring. As the spring moves back and forth, it moves the needle up and down. The tattoo artist stops and starts it with a foot pedal, like a sewing machine. Time to tattoo. He turns on the power supply to 10 volts and dabs the needle in the ink cap. The gun sucks up the ink. Some petroleum jelly on the skin helps the needle glide more easily. He begins by tracing the lines of the blueprint. The needle punctures the skin at a rate of up to 3,000 times per minute, injecting microparticles of ink which intermingle with the cells of the dermis, the skin's second layer. The artist continually wipes away the excess ink to keep his work area clean. After finishing the outline, he reapplies petroleum jelly. This seals the pores of the skin and prevents bleeding. Then he changes to the other needle and begins shading and coloring the image with a back and forth movement. He applies one color at a time, overlapping them to ensure thorough and even coverage. The needle can penetrate from 1 to 4 millimeters, and a good tattoo artist knows just how deep to go to create the different parts of the image. For example, he has to inject the outline the deepest, but going too deep can tear the skin and cause excessive pain and bleeding. But not going deep enough misses the dermis and leaves marks after healing. The cells of the dermis are remarkably stable, so tattoos last a lifetime. This tattoo has taken approximately 45 minutes to do from start to finish. The area will dry and scab over. Then, the scab will fall off, and this body art will be ready for exhibition. Believe it or not, World War I led to the invention of disposable sanitary napkins. American nurses serving in France discovered that the bandages they used for the troops could double as very absorbent menstrual pads. This led the bandage company to introduce disposable sanitary napkins in 1921. Today's disposable sanitary pads are made of layers of cellulose combined with superabsorbent polymer powder. Polymer is a fluid-absorbing chemical derived from either petroleum or wheat. Cellulose is the fiber that makes up the cell wall of trees and plants. It also retains fluid. Pulp and paper companies grind and moisten it to form a product called pulp. Producing sanitary napkins begins with half-meter wide rolls of cellulose pulp. The rolls feed one long machine that does everything. First, knives spinning at 3,000 RPM shred the pulp into a fine fluff. Then the machine sprinkles that fluff with polymer powder. The polymered fluff then travels through what's called the doser, a device that measures out the required amount of fluff per pad layer. The machine then suctions each dose into a closed chamber where an air current blows it into a pad-shaped mold. Then another air current blows it out of the mold onto a wheel that transfers it to a conveyor belt. The machine simultaneously makes a second pad layer. This one is smaller, rectangular, and at least double the density of the first layer, meaning it has more cellulose compressed into a smaller size. The compression roller also embosses a pattern that will disperse the menstrual flow, helping absorption. This demonstration shows the critical absorption role the polymer powder plays. It can retain up to 40 times its volume. As the polymer soaks up the liquid, it transforms from powder to gel. Different types of polymers have different reaction speeds. This type absorbs at average speed. This will be a 2-layer pad. The number of layers and their weight depends on the degree of menstrual flow a pad is designed to absorb. Now the machine's conveyor belts merge, bringing the 2 layers together. Now the machine sandwiches the layers between plastic sheets. The top one is perforated to allow fluid to pass to the absorbent layers underneath. The bottom one acts as a leak-proof barrier. A roller stamps the contour of the pad, sealing the absorbent layers inside. Now the machine applies glue to a paper strip and to a pair of small paper rectangles. It slaps the strip on the back of the pad and the rectangles on the side flaps, called the wings. To secure the pad to underwear, you remove the paper to expose the adhesive. The pads are still connected to each other. A cutting die excises each one. Abrasive foam on either side of the die grips and pulls away the material surrounding the pads. A vacuum then sucks this excess away. Now the pads move on to the packaging line. The equipment first folds over the adhesive wings, then folds each pad in 3.